Hello, welcome to this video about comparing objects. So how do we compare objects and what do we need that for? We often need to compare objects when we want to sort things. And there are many different ways of sorting objects based on their different properties, and we'll try to look into that. I've implemented an example of a simple object and a more complex object, and we'll look at the problem that's going to be there when we need to sort them. So I did that beforehand, and what we can see here now is that I have an array list of numbers. So I have the number 1, 4, 3, and minus 23, and they're in no particular order, just something I cooked up. I then print them out to the screen. The next thing I do is I have a list of persons, and I create 3 new persons, one called Peter, John, and Jenny, and they all have different ages. Again, no particular order, just something I came up with. I print them out here. So let's say we want to order these lists. We can actually do that. So there's some built-in stuff in Java for ordering the list. For example, here, if I say numbers, not bumpers, numbers.sort, we could sort the list, but it doesn't really work because it says it needs a comparator. So we need to specify that. If we don't specify anything, we can actually specify null and run that. Let's see what happens. So now we can see that it puts them out in order actually, like we wanted, minus 23, 1, 3, and 4. So when we have something like an array of numbers, which is a simple object, integer here is a very simple object, then it's pretty easy because there's only one way to sort them. So now they are ascending order. We can look at later how can we sort them descending and so forth. But right now the interesting thing is just that this is pretty easy. Integer object is already built in, so that's self-explanatory. If we look into something oftentimes that's not built in, for example the person here, if I go in here we can see that the person has a name and an age. So when we are sorting the person, how do we want to sort them? So if I do persons dot sort null here, it would be interesting to see how is it going to sort that. Oop, it says cannot be cast to Java lang comparable unnamed module loader app. So we can't even do that. So there's no way we can do that because we need to implement a method in order to be able to sort something like a person. So let's go into the person. So what we can do in here is we can use something, a method called a compareTo. I should have written it here, I forgot about it, but we can do that. So I even think it's built in to IntelliJ. We can just go right click and generate, and then no, it's not really, so let's do it. So override, and then we'll say public compareTo. And the method compareTo only works if we make the class comparable. So we're going to say person comparable. If I do this, it will create it for me. So implement methods here, and we'll see here now I have the compareTo. That was what I was hinting at here. So now we have a compareTo method, and in this case we get an object, and then it simply returns 0. So that means that it tries to compare to this object with the one we're inside of, namely, so this is the object that we're inside of, and O is the other object. The problem with this is it's hard to compare an object because if I type O here, we can't really get any of the properties from it, so we can't use the get name or anything like that because it's an object. So if we use the comparable interface, we should use it with the generic. So let me show you. We go up here, you see comparable, and then we can say person up here. So then we implement methods again. Didn't catch that? Okay. But yeah, it changed it to person here. So I don't like to call the person O, so we'll just call it person. So now we have a person, so we can say something. So it's like this. So if the we need to compare these persons and return an integer. So it compares the object, and if it's 0, then it's the same. So we are considering them to be equal. And if it's less than 0, we consider the second one to be the largest one, and the other way around. So for example, I can say for the person, let's go for the age, we can say person dot age minus this dot age. So this will compare the age of the person we get here with the other one. We might say you should maybe use get age in this case, probably be more correct. But this way we'll get a negative number if the age for this person is lower than the other. Let's try to run the method then. So now it's sorted, and we can see that John is on top, so he's 31, and then it's Jenny, and then it's Peter. So we can implement the compareTo method, and this way we can have like built into an object how it compares to other objects. So this is to use the comparable interface, which is pretty cool. This gives us some problems though if we go back into main here. So now that we can sort a person like that, what if we want to sort it in reverse or something like that? What if this is not the correct way? Then we can of course say, okay, that I can solve that. I'll put this here, and then I'll put person here. Then now it's sorted the other way. So now it's 25 first and so forth. So now comes the next problem. So oftentimes when we're working with something we want to sort it in different ways. So maybe for these persons here, this time I want to just sort it by the built-in way of sorting it, but another time I want to sort it in another way, and sometimes I want to change that. But if it's built into the person, it's always sorted the same way. So how can we actually fix that? So we can see that sort has something called a comparator that we can use. So when we want to sort a list of persons, we can use this comparator instead of the null to actually sort it any way we want. So this is for the second. We need to use we use the comparable interface, and now we want to use the comparator. So what we actually need to do is in here, when we want to sort it in a custom way, we need to specify a comparator here. And a comparator is an instance of an object, that instance of a class that extends the comparator into the comparator class. So let's see here, like new, and we can then take interface comparator for person, and then we can actually see we get the same comparison as before. Now the difference is that now we have person 1 here and person 2 here, because now we are not inside of the class, we are outside of the class, so we cannot use this here. So we create a comparator, so we kind of take the logic and wraps it into an object that's called a comparator object. And that means that we can, in here, we can say O1 minus, sorry, O1 minus O2. So we take, let's call them P, because it's very hard to see here. So we say P1 minus P2, and we want to get the age like that. So now we can sort it by age. So right now 25, 29, 31, and still 25, 29, 31. And like before, if I change these two, then they will be sorted in the other direction. So that is pretty cool. So now it's not person that decides how persons are being uh, sorted, but actually we have another class where we can find that. So what we can do is we can create another class where we create a new comparator, and then we can add that. I can show that real quick how to do that. So we can even have like a new class here. We'll call this person age comparator, like that. And we're going to say that it implements the comparator interface and for person, like that. And that means that now we want to implement the methods, and it has the compareTo. So in here we can then write O1 get age minus O2 get age. That's it. So the cool thing about that is then we don't need the code in here. We kind of have generalized how to do that. So now we can just say new person age comparator, and that's it. So we could also call it something else. Maybe we can call it sort person by age and descending, something like that. And then of course I need to rename the file. And in here, do that. So I say new sort person by age descending. So now we know this is pretty cool. We have this class that we can define somewhere else that can sort persons like that. And we can have like a range of these classes. We can have sort by age. We can also create another class where we can sort by, let's do that, like where we sort by name instead. Java class, let's call it sort person by name descending. And this one also implements the comparator interface. And again, we need to do it for person because it only works for persons, this one. Nice. And I can then say I want to implement the method, and I want to implement the compareTo method like that. And in here we can then say O1 dot compareTo O2. That's not good. So what I wanted really was to get the name and then use the compareTo the name of O2. So when we use the compareTo on the string object, it's already implemented. So it will sort names alphabetically. So first I get the name for the person and tells it to compare it to the name of the other person. So that should sort it alphabetically. So now I can change this around, sort by name descending, and then it simply spits out by name. So Jenny comes first, and then John, and then Peter. So that sounds pretty it seems pretty good to me. So this is the comparator. So it's a really cool little thing you can do to take the logic and put it into something else, somewhere else, so that it's not inside of the person, because in many ways it's wrong to put the comparison between two persons inside the person. Often we want our logic out of these classes. Often we only want classes like this, like business entities they are called, or POJOs sometimes. We only want data in here. We don't want logic on how they should be compared or calculated in any way. We want that elsewhere, because it gets hard to maintain, because if one class uses person and sorts it, then another class uses person and wants to sort it in another way. They might change the compareTo and it breaks the other class. So having it externally like this makes it a bit easier to do, and it also enables us to sort it differently in different cases. So if we want to sort it in one way in one place in our system, we can do that, or sort it in another way in our system, we can also do that. You might also be wondering why I didn't show lambda expression. So we can also do, instead of saying new comparator of person like this, we should also be able to simply do a lambda expression. So let's try that. Something like this, lambda expression, and then we should only need person 1 and person 2, and not all of this stuff here. And then in here we say person 1 get name, compareTo person 2 get name, something like that. And then I don't need these. So in here now I have instead a lambda expression that does the same thing. It kind of just hides the new comparator and all of that stuff. So I wanted to show you that you can do it like that also. And I think this is somewhat easy to read, but I actually think by using the comparator in another class, it's actually easier to read, and you put it out of this class and into a specialized class that you can actually reuse over and over again. So this has some benefits to this method, and especially the benefit I think it's easier to read, and the other benefit that you have it somewhere else. But I think in most cases, most implementations, you would see something like this. Then there's also the possibility to use comparing. It's kind of, you can use something called a key selector. So let me show you that as the last thing I want to show in this video. So IntelliJ is pretty smart on this, so it already says, why don't you replace this with a comparator.comparing here? So let's try to do that and see what happens. And I really like this. So what you can see here is that this is a newer way of doing it. So what we can say is we can use the comparator class. It has a static method inside of it where we can specify a link to the method of the person that we want to sort it by. So instead of writing all the other stuff, I really like this way of doing it, because we're saying we have a comparator, we want to compare the names of the persons, and that actually works out of the box. And I promise you the lambda expression also works, but this works out of the box. Should work out of the box. Oh yeah, it's by name. I was just confused here. Yeah, it's by name. So, and if we want to change it into something else, we can easily say we have get age and get name. What about age? Let's sort it by age. So that is actually pretty cool that you can do something like that. So sometimes you would also want maybe to sort it reversed or something like that. So what about just typing reverse then? And then it's reversed. So I really like this way, this key selector thing, and using the comparator like this, because it's very easy to read, I find. We get the easy to read that we got from this without having to create the entire class, but the logic is still in here. But I think it's kind of doable because, yeah, it's logic on the age here. I think it's okay. So comparator comparing person, and then 2 colons, and then we say which method are we going to compare on. So this should return some value, otherwise we can't use it, right? So when we have this to return the value, we can compare on age, and we simply just say dot reversed. So it's pretty cool. and it uses this builder pattern, which is pretty cool. So we can say reversed, and then we get something back, and then we can do more. So one of the cool thing is we can say then comparing, and then we can compare the next thing. So again, we can put in the uh, comparator here. I don't know why it pops up with all of this stuff. Comparator, comparing, and person get age. So it looks a bit odd here. But basically we're saying here, let me just move this to a new line. It gets a bit long here. Didn't help much. So we are saying compare the person by age reversed, so it will come in opposite age. And then afterwards, then we compare it by, sorry, name here. So that means that it will do it by age first and then by name. So let's try to make another person here. I'll just add one because otherwise we can't see that it's actually taking the results of the first. It actually takes the result of this first. So it takes it by age, and then it says, I want that, but I want it reversed. Now I have the reversed version of that. After that, we say, okay, then we compare it again, and now we look at the name. So let's have another person that's 29. Let's call this person Joe, like that, and let's see what happens. So we should get the age reversed, and then Jenny and Joe should be in alphabetical order, which they are. And we can try to test it by putting in one more person here in the middle. Jill. So now we have 3 persons aged 29. And they are all in the middle here, and they are all alphabetically sorted. And again, we can keep piggybacking onto this. So we can say reversed on this, or we can even say this will reverse the entire thing, but we can also reverse only this part here. So this is called a builder pattern, which is a pretty cool pattern for this. So I think that's basically what I wanted to show. If you're interested, you can look more into the comparator. It has a couple of other like cool moves, but I think these are the best ones that you would learn. So you can, yeah. So different ways of different things. If you have simple data types like just an integer, you might not want something like this. You just want to do it like this, but you can still imagine that you can do the same kind of comparison here using the comparator. So I think definitely use this comparator whenever it makes sense, and only maybe in the case where you have like complex logic or something like that, I would create its own class here so that I could have the logic in a class by itself. Thank you for watching, and that's it for now.